Researchers choose Salford because of the vibrant research community here, which has very close links with industry. Our fundamental research in the area of materials and physics has links to other areas of research within the university, including energy studies and artificial intelligence.
My research focuses on exploiting experimental physics to understand and develop novel light harvesting and light emitting materials. I'm using a variety of laser-based time-resolved techniques. I use ultra-fast femtosecond laser systems to perform transient absorption spectroscopy and nanosecond laser systems to perform flash photolysis, which is basically when you first excite your sample with a very strong light pulse, and that could be femtosecond or nanosecond duration, and then you come with a second pulse and you monitor the changes in your sample over time. These techniques can provide very important information on carrier dynamics from femtosecond to nanosecond timescales.
My own research involves studying how different materials behave under extreme pressures and temperatures. So the kind of conditions found in explosions and impacts, and also in planetary interiors. So we study materials primarily experimentally using Diamond Anvil high pressure cell. We do work, optical spectroscopy work in the lab here at Salford, and then also we do work at central facilities such as the Diamond Light Source, the Oxford European Synchrotron facility, and the ICES Pulsed Neutron Source. So this is one of the Diamond Anvil high pressure cells. You might start with think that we do high pressure research using a really massive piece of apparatus, but actually since pressure is energy density, we need to use a very small piece of apparatus and a very small sample. So at the end here, a tiny sample about 0.1 millimeters diameter sits where it's confined under extreme high pressures using the diamond anvils, and so we turn the screws to apply the pressure. And this is one of the high pressure cells that we use when we do experiments also under high temperature. This is why it looks a bit charred from years of cooking basically, and we clamp a heater around the high pressure cell to apply the high temperature, and have another one inside still with wires sticking through the little port here.
My research is on the production of functional coatings which can be put on substrates such as glass, metal, and depending on the exact process, plastics. The deposition is done by a process called chemical vapor deposition, or CVD, which is a process used routinely in industry for both inline and batch production. In my lab, my coaters mimic this. A wide range of coatings can be produced, which include transparent conductors, charge transfer, anti-reflection, antimicrobial, hydrophilic or phobic properties. These all have applications in solar cells, infection reduction surfaces, low E and self-clean glazing.
My own particular research is in the atomistic simulations of materials, and this mainly encompasses so-called first principles methods to try to predict the properties of materials. This starts with the fundamental laws of quantum mechanics that describe how electrons behave in materials, and utilizes high performance computing to do the calculations.
So one of the materials that we look at here is erbium implanted silicon, and this is quite an unusual material. It's not looked at by many other researchers, but it's got lots of properties that could be useful for quantum technologies, and we've had some really exciting indications that it's got some very useful properties for quantum technologies, and here we're trying to measure this material and find out more about it, because there's a lot that's not very well understood about this material. The research we're doing here at Salford is really exciting. So some of the things we've found out about erbium implanted silicon could make it really useful for building quantum technologies, quantum computers or quantum communication systems. So this is a really cutting-edge material, and we're right at the start of the journey of understanding this material and finding out more about it.